A way in which we can find the vertex of a parabola when it is written in standard form is to utilize the following information. All right. We talked about this a little bit in class before, but to find the x-coordinate of the vertex, it can utilize this info that the x-coordinate will be equivalent to negative b over 2a. Notice that the 2a there is in its own set of parentheses, but that will give us the x-coordinate of the vertex. And then once we know that value, what we will be able to do is take that specific number, plug it back in for x in the original quadratic we're given, and the output there will be the y-coordinate of the vertex. Okay, so we'll see that in a couple examples here. A couple other things to note. If your value of a is positive, like we've talked about in the past, we will have a minimum. The vertex will be located at a minimum. And then if the value of a is less than 0, the coordinates of the vertex will represent a maximum. So if you read through example 6, we're given this quadratic. All right. Big component here is identifying what your value of a and b are equal to. What we're looking at here is, ideally, we want to find the maximum height reached by the baseball. So with the quadratic we're given, the value of a is negative 0.0032. Our value of b is 1. So if we utilize what we know, x equals negative b over 2a. Notice that I did put the 2a in its own set of parentheses. All right, here's our value of a, and then our value of b, which would come from that x is just 1, so we'd have negative 1, the opposite of b there. And if we calculate that, and I encourage you to put negative 1 divided by 2 times negative 0.0032 in your calculator, you should get 156.25. So that gives us the x-coordinate of our vertex. All right, to find the y-coordinate of the vertex, we'll take that 156.25, and we will plug it back in to our function. Okay, so we'll replace x with 156.25. So when we find f of 156.25, you can see we have it written out there, and all we have to do is type that into our calculator, and we will get 81.25 feet. All right, and so it's important to understand what the question is asking. What we were looking for was the maximum height reached by the baseball. All right, we are told in the problem that f of x is the height of the ball. So our final answer here, the maximum height reached by the baseball would be 81.25. Just to extend this a little bit further so we are completely clear on what's going on, if we looked at a graph of this, our graph would look something like this. All right. This point up here would be 156.25 for the x-coordinate and 81.25 for our y-coordinate. So that, again, gives us our vertex, which is a maximum. Similar situation here in example 7. All right, we have a cost equation, 100,000 minus 110x plus 0.045x squared. We're told C is the total cost in dollars and X is the number of units produced. We want to figure out what the minimum cost would be in this case. So again, it's important to identify from the quadratic we're given the values of A and B. All right, we can use this, our knowledge of X equaling negative B over 2A. So in this case, you got to be careful. A, again, is the value that is in front of X squared. So there's our value of A. And then in this case, our value of B will be negative 110. All right. So continuing on from that point, X will equal 110 over 2 times 0.045. Again, it's just positive 110 because it's negative B over 2A. When we simplify that, we will end up with 100 or 1,222.2. And we would round that down to 1,222 units. And we can stop there. We do not need to plug that back in to figure out the total cost. We could find that by plugging 1,222 back into our function, but we don't need to because it just says how many units should be produced. So we can just stop there, and this would be our final answer. Okay, for the next portion, what we're looking at, we're going to find two positive real numbers whose product is a maximum if the sum of the first and 3 times the second is 42. All right, So we want the product here, as it says, to be a maximum. So we will have a particular function, and it'll be f of, depending on what we want to make our independent variable. So you can see there I have a question mark. That will equal two numbers multiplied together. So I have that represented as x times y. We are also told that the sum of the first and 3 times the second is 42. So our first number, if I consider that to be x, we would have x plus 3 times the second. If my second number is considered to be y, it would be x plus 3y, and that equals 42. So what we can do between these two equations right here is create a quadratic, all right? And we can do that by solving this equation for either x or y. So it would be easiest for us to solve that equation for x. So we'd have x equals 42 minus 3y. And now that I know what x is in terms of y, I can take this value, 42 minus 3y, and since that is equivalent to x, I can plug that back in here for x. So that would make our function, instead of having f question mark, I can say that that is now f of y, and that would be 42 minus 3y. So we just replaced this x with 42 minus 3y because, again, we know x is equal to 42 minus 3y. And y is the variable that we're dealing with, so that is why we call this f of y. All right. So that will become a quadratic now. All right, we'll have f of y equals 42 minus 3y squared when we distribute this y through. And now that we have a quadratic, what we can do is figure out the maximum by utilizing our knowledge of negative b over 2a. So in this case, it'll be y equals negative b over 2a. So the opposite of b in this case will be negative 42, and then our value of a is negative 3. So we'll have negative 42 over 2 times negative 3. That comes out to be 7. So now that we know that y is 7, we can take that value, plug it back in here, and we'll have x equals 42 minus 3 times 7, or x equals 21. So our two numbers here that would yield a maximum and meet that second criteria that x plus 3y equals 42 would be 7 and 21. Okay, the final problem in the marathon of the 3.1 notes deals with maximizing an area. All right, so you can see here we have a rectangular yard, and we're going to fence that in, and the fence is going to go all the way up to the lake because that's extremely practical. So anyway, to represent this situation that we have within this, you can see I have that picture to the left. All right, it's a 3-sided fence, and I just labeled it, length, and then the width. If it's rectangular, those opposite sides will be the same. Okay, so we're trying to maximize the area. All right. So if we were to do this, we need to create a function that represents area. So we know that area of a rectangle is length times width. Pretty straightforward. All right. We also know in this problem that we have 400 feet of fence to use. So if we want to maximize that area, all right, and we're using 400 feet of fence, we can represent the perimeter of the amount of, something that represents the amount of fence we're going to use. We have w twice, so 2w, and then the length. We know that when we add up w plus l plus w, or 2w plus l, we will end up getting 400, okay? So just like the last problem, what we can do is define either L, solve for either L or W within this equation right here. So if I solve for L, I'll have L equals 400 minus 2W. And then to create a quadratic, so I can utilize our knowledge of negative b over 2a, I can take the 400 minus 2w and plug it in for L back here. And that will give us a equals 400 minus 2w times w. All right, so again, I just replaced this L with this right here. Because again, we know that L is equal to that. So now we can distribute the w through, and that creates our quadratic that we need. And now we can utilize our knowledge of negative b over 2a. So Opposite of b would be negative 400 divided by 2 times our value of a, which is negative 2. So that gives us a width of 100. Once we know that the width is 100, we can plug that back in right here. So when we do that, we'll have a length equaling 400 minus 2 times 100. So our length will end up being 200. So two things that were asked here are what are the dimensions? So our dimensions would be 100 by 200. And then to find the area there, we would just multiply that out. Okay, so if we complete that, the area 100 times 200 would be 20,000 feet squared. So your final answer there for area would be 20,000 feet squared. That is finally it for the 3.1 notes.